Okay. Hello, everyone. My name is Chuanbin Zhu from GFZ. In this presentation, I'm going to introduce you an open source set database of strong motion stations in Japan. This database contains set parameters for a total number of 1,742 KiK-net and KiK-net stations. Collected set proxies can be grouped into three categories. The first category of set proxies is derived from available 1D velocity profiles. We have both S-wave and P-wave velocity profiles for these stations, and we derive relevant parameters separately. So the profile-based parameters are firstly average velocities to different depths, as well as the velocity at the ground surface and at the downhole. Secondly, depths to different velocity horizons, including 0.8, 1.0, 1.5, and 2.5 km per second. Thirdly, the largest velocity contrast present in the velocity profile and its corresponding depths. We also provide information on velocity contrast that is present in a given velocity profile. The second category of set proxies is obtained from earthquake horizontal to vertical spectral ratios. We devised new peak peaking schemes and use this newly derived scheme to identify HVSR parameters, including peak frequency, peak amplitude, peak width, and peak prominence. Besides these HVSR parameters, we also provide the whole HVSR curves as a function of frequency. The last category of set proxies is inferred from either regional models or maps, and this inferred proxies include geological age, lithological unit, topographic slope, geomorphological unit, topographic position index, terrain roughness index, compound topographic index, anomaly roughness, as well as crustal velocity structure. The crustal velocity structures are derived from a 3D velocity structure model for the whole of Japan. And these crustal velocity structures are down to hard or very hard rocks and can be combined with relatively shallow but detailed KiK-net velocity profiles to present a complete representation of the set condition underneath a station. And we are also very careful with the relocated stations. There are a total number of 126 KiK-net stations that had been relocated before this study. And this relocated station used the same set codes before this relocation. So you cannot tell whether a station is relocated or not by its set code. Some of these stations were relocated a few kilometers away from its previous location. So it's definitely necessary to derive set proxies for these stations both before and after the relocation. This table shows the set condition parameters contained in this open source database. And as a sanity check, we also compared the set parameters in our set database with those available in the literature. And very good agreements could be achieved for almost all the proxies examined. All these described parameters are provided in a profile available online. It's temporarily hosted on the Figshare data repository. So the open source set database has three features. Firstly, it's comprehensive because it's for a total number 1,700 plus slow motion stations in Japan. And secondly, it's homogeneous because each parameter is derived consistently for all the stations. And thirdly, it's publicly available. This open source set database can be used with processed KiK-net or KiK-net ground motion database to search for the optimal predictive variables for ergodic set response models, or to develop set proxy inference models like variability slope correlation relations, or to propose new set classification schemes based on HVSR, or apply sophisticated machine learning techniques in such effect studies, for example, deep neural network or random forest. And this database also enables a panoramic view. Previously, we often interpret our results and check the dependency of our results on variability. But with this database, we can also check its relevance with thickness, rock age, lithology, terrain, and geomorphology. All the tables and figures used in this presentation are from our data paper submitted to Earthquake Spectra. If you want to know more about the database, please refer to the preprint available on my ResearchGate account. The database is also publicly available online and it can be accessed via this link. I want to thank all my co-authors both internally and externally. This work benefits greatly from Ken and Ji-Kun's constructive review. And finally, I also want to thank you for your time.